Well, a friend on this video was bright enough to say that nobody could see where the planet Venus was at this very second, and I'm going to teach the entire world how to do it, or at least as many of the world as cares to look at this. We're going to be using a program called Carte du Ciel. It's a French program which is charts of the sky, or sky chart in English, but I would much rather use the French name because the man who made it is French, and he deserves to be known. So that is his website right there. Now, if you want to download this, you can download it right from this download link here, and you can see right here you have Windows 32 and Windows 64-bit setups. You can download a Mac edition or several different Linux editions. I'm using Ubuntu Linux, so I would just download the Linux Debian 64-bit program, but most of you will be downloading this Windows 64-bit setup, so you download that and then you install it. Now, after you install it, you get the chance to install a whole bunch of different sky charts, a whole bunch of catalogs. Is what it really is, where you can have millions and millions of stars precisely known by their brightness, names, and everything else that you can imagine, including their proper motion. That's their motion through the sky. Stars are not stationary. Those guys move around of their own volition, and this program will show that to you. But that's not what we're doing tonight. Tonight we're going to use this program to take a look and see where Venus is. So let's start up the program here. It's called Sky Chart. There it is. Boom! This is an open source free program which you can download and use for free. It's just an amazing quality program. A very first thing we're going to have to do is we're going to change the time and date. So we're going to take a look at right there, and we're going to use the system time because, of course, the challenge was we need to find out where Venus is this very second. We're going to auto refresh every 20 seconds here just for fun. And today's date and everything is all grayed out because it's supplied by your system. We'll say OK. Next thing we need is we need an observing location. That's right here with this little observatory. And right now I have it set for Montreal, Canada. You want to leave it there? We don't have to. We can go to Richmond, Virginia, or DeLand. I have those two set up. Or we have an entire observatory database in here. If we want to go to Colorado, Chamberlain Observatory in Denver. There we go. University of Colorado Observatory. Let's do that. That ought to be fun. There's the longitude and latitude. We'll say OK, and we've instantly moved to that location. Let's say OK. Now we're at the present. Let's tell it what we want to find, and what we want to find is the planet Venus. So we'll click right up there, and we'll say Solar System Object, Venus. Find that puppy. Hey, look, there it is. Now, right now, we have a coordinate system up here, a grid, and this grid, what we see right here, is altitude azimuth. You can have an equatorial coordinate grid, which basically extends the longitude and latitude lines on the spherical Earth up into the sky. You can have an ecliptic coordinates. Ecliptic coordinates are by the average plane of the planets around the sun. And we also have galactic coordinates, which works by the average plane of the galaxy. But most useful one for us right now is altitude and azimuth, because that will tell us where in the sky to find it if we're at this University of Colorado Observatory in Boulder, Colorado. You notice right now it's 19 hours, 22 minutes, 41 seconds. And we're looking at Venus right there in the center. It's magnitude. Oh, we're not looking at Venus. Venus is not magnitude 10.0. Let's go to Venus. About Venus. Lucky. Okay, so its magnitude minus 3.9. Its diameter is 12 arc seconds. Its illuminated fraction right now. Venus has phases just like the moon because it's closer to the sun than we are, and it's orbiting the sun in a way that makes it have phases exactly like the moon does. So it's phased right now. Illuminated fraction is 0.861. That's the illuminated part here. This is the unilluminated part. Its phase is 44% illuminated. There's its distance from Earth right here, 1.397771109 astronomical units. That should tell you something about our knowledge of the solar system. It's pretty precise. And the distance in kilometers, right there it is. Let's just say it's over 2 million kilometers. Hey? Let's see, 582, 209,103,582 kilometers distant from us. The solar distance from the sun right now, solar distance is 0.718464380 astronomical units. Its solar distance in kilometers is 107,480,741 kilometers. Here's its orbital velocity here at 35.3 kilometers per second. And its pole's inclination, its position angle, its sun inclination, central meridian that we're looking at is longitude 308.6. And you get the date, course, and time, and all that good stuff. It's hourly motion here. You get a lot more information. Here's the observatory location right there. You need to print that sometimes when you're observing. Let's center it on this object. So we are now centered on Venus. Let's read our chart right now, and we can see its altitude and its azimuth right here. We'll put the cursor over it. Its altitude is 248 degrees 3 minutes 33 seconds is its azimuth. West is 270. So it's 250, or actually 248.0333. Its altitude is 59 degrees 51 minutes 2.5 seconds. And below that you see its celestial coordinates here at right ascension, which is 5 hours 14 minutes 46.14 seconds. That is the equivalent of a longitude on Earth. And its declination, that's how far away it is from the North Star in a north-south direction, is 24 degrees 17 minutes 0.6 seconds. Over to the right, we see its rise time and its culmination time. That's when it's highest in the sky. It won't necessarily be straight overhead for you, but that's when it's the highest in the sky. And it will set just after midnight here at 0 hours 33 minutes 1 second. At an azimuth of 302.54, 302 degrees 54 minutes. So here's Venus right here, and as you can see exactly where it is at this second using this program. You saw all the steps that's necessary in finding it. This program has a billion different things that are just utterly fascinating. Like, for instance, we can use time-lapse to just watch Venus move across the sky. So we have Venus centered, so it's going to look like the sky moves and Venus stays still, but that's not true. The coordinate system will tell you that Venus is actually moving. It's moving a little too fast. Let's go find Venus again, and we'll lock Venus. Center on. I want to set target to Venus. Now when we do the time lapse, we will see, this is set up for an hour. Let's go 2 minutes. Each jump will be 1 minute now. It won't go so far. It's going to move 15 degrees per hour, so that's a long ways. You can see right here, 15 degrees is off screen to right here, so that's a big jump. Let's make some small jumps and start the time lapse again. You can see its settings. Notice that it doesn't go straight up and down. It goes on an angle to the horizon. This is the horizon right down here. This line that the planet follows is called the ecliptic. And this line right here is the line of the ecliptic. So Venus right now is slightly above the ecliptic. Let's go back again. We can reverse time. Bring Venus back up. So there we go. So now you know how you can download a free program usable in all the operating systems that are possible. You can also use that program to find where Venus is at this second for any second during your entire lifetime. Thank you very much. Our guy's a liar, isn't he? Bye.